Hello students, so now we are going to solve a question of Laplace equation. How to find out the solution of Laplace equation. So what is given to you, look in this example, solve the elliptic equation u double x plus u double y equal to 0. You know this is your Laplace equation because it is curly square u over curly x square plus curly square u over curly y square equal to 0. So now you have to find out the solution for this one. Okay, and what is given to you? You are given a square mesh with boundary values. This mesh is given to you. Look at this. In this mesh, the boundary values are given. The boundary values are 500, 1000, 500, 1000, 2000, 1000, all these. And these are your mesh points on which you have to find out the values. Okay. Now, it is given that it is a square mesh. This means the value for h and k is same. Okay. Second thing, if you can observe that the boundary values are symmetrical. 1000 on this side, 1000 on this side. 500, 500. Then again 1000, 2000, 1000. Right? So, we will write down that let u1, u2 up to un be the values of u at interior mesh points that we have to calculate. Now, since the boundary values of u are symmetrical about AB, what is AB? This line, AB. Now, the boundary values on this side are symmetrical. This means this value u1 will be equal to u3. Okay. Similarly, this look at this CD, this line, this AB and this CD, they all are having the same boundary values, that is the boundary values are symmetrical. So this implies this u1 will be equal to u3, this u3 will be equal to u9, this u9 will be equal to u7, and this u7 will again be equal to u1. This u2 will be equal to u8, this u4 will be equal to u6. So this all we have written here. That is u7 is equal to u1, u8 is equal to u2, u9 is equal to u3, then u3 is equal to u1, u6 is equal to u4, and u9 is equal to u7. Okay. So this implies if I find out this value of u1, then if I have find out this value, this means I have the value for u3, u9 and u7 because they all are same. Similarly, if I find out the value for u2, so I have the value for u8. If I find out the value for u4, then I have the value for u6, right? So this means I have to find out the value for u1, u2, u4, then this u5, because it is at the center and it's not equal to any other value. So I have to find out the value for u1, u2, u4 and u5. So only these four values I have to find out. So thus, it is sufficient to find the values u1, u2, u4 and u5. So now we will find out these values using our two formulas that we have done already, that is standard formula and diagonal point formula. Okay. So I will find out the value. I will start the value from here, u5. This is at the center. So if I have to find out its value, so I can see that this 2000, this 1000, this 2000, this 1000, they all are at the same distance from this u5, and we also know that this is a square mesh, so they are equal, this is symmetrical. So u5 can be written equal to 1 by 4 2000 plus 2000 plus 1000 plus 1000. That is, we have applied the standard formula. The standard formula told us upward value, downward value, left-handed value, right-handed value. It can be at one distance, it can be at two distances, but it should be symmetrical. If you are taking two distance here, so you have to take two distance here, you have to take two distance here and two distance here. If you are taking one distance values, so it should be one distance for all. So if I am going to take the one distance value, so these all values are unknown to me. I don't have any value for these. So I have taken two distances everywhere. So by that way, I have calculated the value for u5 and this has comes out to be 1500. So I will mention here that whether I am applying the standard formula or diagonal point formula, always I have to mention here. Okay, so after calculating this value for u5, now I have to find out the value for u1, u2 and u4. Now, so look here. So we have calculated this u1 as 1 over 4, 0 plus 1500 plus 1000 plus 2000. How we have taken these values? Come here again. Now here is your u1. So if I want to apply standard formula here, there is only one distance on the upside, so I can't go for the two distances. It is limited here. This is the boundary value. So if I want to apply the standard formula, I have to take up value 500, down value u4, but u4 is unknown, so I can't apply standard formula. So now I will try to apply diagonal formula. So this diagonal value 0, it is available. This diagonal value 1000 available. This diagonal value 2000 available. Then this diagonal value u5, and u5 is known. It is 1500. So all the diagonal values are known: 0, 1000, 2000 and 1500. So using this diagonal formula, I can find out the value for u1. So by this way, we have calculated this value for u1. It is u1 is equal to 1 over 4, 0 plus 1500 plus 1000 plus 2000 equals to 1125, and I have mentioned here that I have applied the diagonal formula. Okay, so now similarly you are going to find out u2. Again come to the same. Now here it is u2. So for u2, first of all try to apply standard formula. Up value 1000 known, below value u5 it is 1500 known, u1 is known now 1125, but u3 unknown. How unknown? u1 is equal to u3. So this means if u1 is 1125, then u3 is also 1125. So this means now I am having the value of u3 as well as u9 as well as u7, because they all are equal to u1. So u1 is 1125, this means it is also 1125, it is also 1125, and this one is also 1125. So I can apply standard formula here. So it will be 1000 plus 1125 plus 1125 plus 1500. So by this way, I have calculated this value for u2. And it comes out to be approximately 1188. If there is any pointed value with decimal, so you can round off it. Okay, so that's why I have written it approximate value 1188. Now this is by using standard formula. Similarly, you can find out your value for u4. Now you have calculated all the values, because you have calculated u1, u2, u4 and u5. So all other values are equal to them. So this means you have all the values, right? So all the mesh points are known now. Now we have to check the accuracy of these values. Are they accurate enough? Now to find out the accuracy of these values, we will apply iteration process. Okay. Now the iteration process that we will apply, we will use the Gauss-Seidel method. We had two methods to apply the iteration procedure. One was Jacobi's method and the second was Gauss-Seidel method. So here we are going to apply the Gauss-Seidel method. Now how to write down the standard formulae using Gauss-Seidel method? You have to write down the values of u1, u2, u4 and u5, the values that you have calculated. Not all the values of mesh point, because they all are same to them. So if you will accurate these values, they all other will become accurate automatically, right? So you will write down the standard formulas for u1, u2, u4 and u5. Only standard formulas, not the diagonal formulas, only standard formulas. Okay, because the Gauss-Seidel method and Jacobi method, their formulas we write using the standard formulas. Okay, so look here. For u1, the standard formula is boundary value 500 plus boundary value 1000 plus u4 plus u2. The boundary value will come as it is. There will be no notation for this. It will come as it is. Only you have to write the value for this, the name for this. Okay, so I had told you how to write down the Gauss-Seidel method. Come here, this was your Gauss-Seidel method. You have to give n plus 1 name to the value lying at this position and this position. This is the left position and this is the upward position, right? So come here. This is the left position and this is the upward position. These two must get n plus 1, but these are constant values, so there will be no n plus 1, no n. Fine. So how to write down this u1? This is your left side value, this is your right side value, this is your upside value, and this is your downside value. Now the left hand side value should have n plus 1, but it is constant value because it is at boundary point, so there will be nothing. Now the right side value should have n, so there is n. The upside value should have n plus 1, but it is again constant, so it will be as it is. Now this is u4, the downside value, it is having n. So now come to the u2. For u2, up value is boundary value, so there will be no n plus 1, but the left value is u1. So at u1 I will put n plus 1, and the right value and down value will get n, that is u3 and u5. I am just applying this Gauss-Seidel method. It says that the left side value and the upside value contains n plus 1 and the other two contain n. Okay. So for u2, this u1 is at the left hand side, so it has n plus 1 on it. Just wait. This u2. The left hand side is u1, it contains n plus 1. Now the right hand side is u3, but u3 is equal to u1. Okay, so that's why at the place of u3, I have written here u1. And u1 is on the right, u3 was on the right hand side, so I have put it here n. This is the value for u3, but u3 is equal to u1, so I have put it u1. I want to keep my all formulas in these forms only, u1, u2, u4, u5. I don't need here u3, u6, u7, u8. I don't need them because they all are equal to these values. Okay. So from where this 1000 comes in case of u2, the 1000 is the upside value and the u5 is the downside value. So 1000 is the upside value. It should contain n plus 1, but it is constant, so it will be as it is. This is the downside value. It will contain n. Right. Now come here, u4. Now for u4 again I will write down my standard formula. This is u4. So the upside value is u1. It will contain n plus 1. The left hand side value is constant 2000, so it will be as it is. The right hand side value is u5. It will contain n, and the downside value u7, it will contain n. Now u7 is equal to u1. So at the place of u7 I will again write down here u1. Come here. For u4, this is right hand side value as it is, left hand side value as it is constant. This is the right hand side value. Then upside value will contain n plus 1. This is downside value, that is u7. Now u7 is equal to u1, so I have written here u1 and with n. Similarly you will write for u5. Okay, so now these are your this is the set of standard formulas on which I will apply iteration process. Starting with the first iteration, now what you will do? Put n equal to 0. So when you will put n equal to 0, it will become u1 1. This term will as it is, it will become u2 0, it will become u4 0, right? Now, what is u2 0? It is the initial value that I have calculated for u2, that is 1188. What is u4 0? It is the initial value for u4 that I have calculated 1438. So I will put all the values here. The boundary values will be as it is constant. So value comes out to be 1032. Then apply the same for u2. Put n equal to 0. So it will be u2 1. 1 over 4. u1 1. Now here I put n equal to 0. It will become u1 1. So u1 1 is this value that I have calculated here. So I will put it here. The recent value is used. Okay. Then it is u1 0. So u1 0 is the last value that I have calculated, 1125. So I will put it here. Then it is 1000 as it is. Then u5 0. So u5 0 was 1500. So put all the values, find out the value. So this means in your formula you have to use your recent value as well as your previous value. Previous value and recent value all are used in the formula. Okay, so by same way you can calculate for U4 and U5. Now this is the set of the new values. If you compare these values with the last values, for example, if I compare this value for U1, it is 1032. Initially U1 was 1125. A lot of difference. This means the values are not same. So I have to repeat the iteration process again and again. The iteration process will be repeated until this U1 value will be equal to the last iterated U1 value. U2 value will be equal to the last iterated U2 value. They can be totally exactly equal or approximately equal. Okay, so if I go to iteration number 2, in iteration number 1 you have to start by putting n equal to 0. So your iteration number 2 will have n equal to 1. So here you will put n equal to 1, so it will become U1 2, it will become U2 1, it will become U4 1. You will put all the values and you will get the answers. Then you will compare this value with this one, the value of U2 with U2, the value of U4 2 with U4 1, the value of U5 2 with U5 1. They are not equal. They are not even approximately equal. So this means I have to repeat this iteration process again and again. Okay. So similarly, keep repeating the iterations and you will get there is negligible difference between the values. When you will keep on repeating this procedure and you will reach at your 11th and 12th iteration, then you will get to know that there is a negligible difference between the values, and then you will put them the final answer. So when you will get the values approximately equal or exactly equal, that will be your answer. So now this is your answer. This means if U1 is 939, so U7 is 939, U3 is 939, all the values. U2 is this, so what was equal to U2? It was, I think, just wait, we will open our table. Look here, U2 is equal to U8. So if I got my U2 as 1001, this means my U8 is also 1001. I got the value for U4 as 1251. So this means U6 is also 1251, right? So I got all the values. U1 I got 939, so this means U7 is 939, U9 is 939, U3 is 939. They all are equal. This is equal to this, this is equal to this, this is equal to this, this is again equal to this. Okay. So by this way, we calculated all the values for these mesh points, and then we also applied the iteration procedure to accurate them, to find out the accuracy. So this was all about a question of Laplace equation. First of all, you will find out the values of all the mesh points, then you will apply the iteration procedure to correct them. Okay, now we will go to the next question, example number 2. Now in the example number 2, given are the values of ux, y on the boundary of the square as given in this figure. And evaluate the function this satisfying the Laplace equation. So this is the question for Laplace equation, and we have to find out the iteration procedure using this Gauss-Seidel method. It is given. This is your question. This figure is given in the question, but if you look at this figure, you will find out that the boundary points, they are not symmetrical. Now 2000, there should be 2000, but there is no 2000. There is no 1000 corresponding to this. So this means here the region is not symmetrical. This means this U1 is not equal to this U2. This U2 is not equal to this U4. This U4 is not equal to U3. They all are having different values. So the values will be same when the region given is symmetrical, that the corresponding boundary values are same in this way and in this way. But here the values are not symmetrical. You can see. So in this case, all the values are unknown to us. No value is equal to any other value. If I want to find out the value for this U1 using standard formula, there are two unknowns. If I want to find out the value using diagonal formula, there is one unknown. Similar in case of all. This means I can neither apply standard formula nor this diagonal formula, because always there is one or two value which is unknown. So the question like this can be solved by using a assumption. What is the assumption? We will assume that any one of these values is 0. Okay, so to get the initial values u1, u2, u3, we will assume that u4 is 0. We have just assumed, it is not 0 actually, we just have assumed that it is 0. So if I have assumed it is 0, so this means I got its value u4. So now I can find out the value for u1, because in the case of u1, if I apply diagonal formula, so it will be 1000 plus 1000 plus 2000 plus u4. Only this u4 was unknown, so I put u4 0. So I will get the value for u1, that is 1000. I will put it here. Then now find out u2. u2 is, if I apply the diagonal formula, so there is u3 that is unknown. So I will apply standard formula. 1000 plus u1 is 1000 plus u4 is 0 plus 500. So I got the value for u2, that is 625. Which formula applied? Standard formula. Okay. Then in the case of u3, again I can't, I can apply diagonal formula here as well as standard formula. So if I apply the standard formula, it will become u1 plus 2000 plus u4 plus 500, and the u1 is 1000, u4 is 0. So I got this value 875. Now I will find out this u4. Now u1, u2, u3 are known. So now I can find out this u4, again applying standard formula. This u2 plus u3 plus 0 plus 0. So I got it 375. So now these are my values for u1, u2, u3 and u4. This is the value for u4 now, not this one. This just I had assumed. Okay. So in the question where the boundary values are like this, that the given region is not symmetrical, in that case, if there is no center value, that you can apply the standard formula. There is no center value where the standard formula can be applied. Just in the case of last question, if you have observed that this was your center value, so you just applied two distant standard formula and you got the value u5, and then you calculated all other values, right? But now in this question there is no center value also, so you have no other choice but you have to assume. Okay, so this is another question that you have to remember, that if the boundary values are not symmetrical and there is no center value, in that case you have to assume a value 0 so that you can get the values for all mesh points. This is done. Now what you have to do, again you have to apply your iteration procedure as you did in your last question. You can apply either your Gauss-Seidel method or Jacobi method, and then you will get all the values for u1, u2, u3 and u4. Do solve this question, do complete it. If there is any